the R language itself is not that user friendly if you use its own GUI. So we have to use R Studio, which makes our lives easier to work with. Now, if you go to the website R for Social SD and Netlify.app, you have module 1, 2, 3, 4, 5 in order, and you have a dummy dataset as well. So first of all, let's go to this website and start downloading the student evaluation.csv file. Just click on this, it will get downloaded. You will be directed to the website. You can download it from here. Just download, click download, and it will be downloaded. You can also download this to your folder. Right. Then we have few other instructions as well. We have student survey.xlsx file as SL file. So you download that one as well to the same folder. That is just to get a familiarity with different types of data types and different versions of data, CSV one type, Excel one type. Okay, we'll start with module 1, introduction to R and R Studio. So we have this little thing here, installing R and R Studio. Click on this, it will open up a slide so that you can follow. Let's read the objective first. Familiarize the participants with the R environment and R Studio interface. Introduce basic R syntax and package usage. By the end of this module, participants should be able to navigate R Studio's panes, execute simple R commands, create variables, and load R package. So that's the objective. Let's go and install R first. Downloading R. To begin, visit the official R project website, which is available here, CRAN, the Comprehensive R Archive Network. If you click on this link, you will be directed to the CRAN website. So the CRAN website looks like this. You have download R for Linux, download R for Mac OS, download R for Windows. Now, Power BI was only available for Windows, but R can be used with all these 3 operating systems, Linux, Mac OS, and Windows. So depending on your operating system, you can click on the link. So I'll click R for Windows here. You will be directed to install R for the first time. If you have not installed this in your computer, so click on R, install R for Windows, and go ahead and download and install it following the usual way. Download R 4.5 for Windows, and if you click on this, it will ask you to download it, the exe file. I'm not going to download it because I have it. You can go ahead and download it and install it. Take your time and download it. While you allow it to download, let's read through the remaining part, right? So I have given the instructions here. For Windows users, click download for R for Windows base and download the latest version. For Mac, you follow that. So and so. Downloading R Studio. After installing R, visit the R Studio desktop download page. So click on the R Studio desktop download page. You will be directed to R Studio desktop web page. It is owned by POSIT. So you can see the name posit.co, posit.co. They own the R Studio, right? So this is R Studio desktop, and they have their own set of instructions. You can accept all if you want, or reject all, just accept all. So the first thing they ask you to do is installing R. So we have already installed R, or if you have not so, you have downloaded R. So your next task is to install R. You can use your exe file and install it. Just double click it and it will be installed. Once you install R, that's the first thing that you have to do. The second thing is installing R Studio. It's like Python, and then you install VS Code or Jupyter, because you have the language and you are using an integrated development environment to work with the language. So you install the R and then you are installing R Studio. That's the second step. You can download R Studio Desktop for Windows just by clicking on this. It is 281.24 megabytes. So it will take some time depending on your internet connection. Will take 5 minutes to download and install. Please, for everyone's sake, once you install it, just send me a message to the chat. Send it to everyone so everyone knows that others could download and install it. So once we hit a certain number, we will start working with it. So go ahead, install R and install R Studio as well. Once you've done both of this, just send a message into the chat informing everyone. All right. Right. So some of you have completed it. Thank you for sending the message. So we within 10 minutes, like around 4, 5, 6, were able to done it. Right. Let's now go ahead and check what we have. So if you have installed RStudio, you can access RStudio by typing in RStudio on your Windows search bar or start menu. You'll get RStudio like this, or just type in the search RStudio, it will take you there. Or of course, if you have a desktop icon, you can double click and get in. When you install, I think the instructions were there. When you install, you might be asked to set what is your R, where your R was installed. I think you have set it up properly. I think it automatically takes where the R is installed, so you don't have to worry much about that. Now, let's go ahead and open RStudio. RStudio, open. You should also see a similar window. On this window, you will have few important things. First, let's get familiar with this. In the meantime, some of you might already get this thing installed as well. So I'll just be a bit slow in doing this so that everyone is on the same page. When you open the RStudio, you would see there are few windows. So the first one is console, then you have terminal, you have background jobs, right? So that's the left hand side. The right hand side will have environment, history, connections, tutorial. You can access RStudio tutorials. You have a lot of important learning things there. You can go ahead and learn from those tutorials as well if you get stuck or if you need some help. Of course, now you have a lot of other ways to learn. Right. So then below this pane, with this window, you have files, plots, packages, help, viewer, presentation as well. So each of these things are called different names. Now, if you go to the website, R for social science, you can see the interface. You have source, console, environment, plots. So source is the source part here, and the console is the console that you see. I'll show you what is source. Now, if you open your RStudio, you can go ahead and click on this little window here. There are a few window icons. If you click on this one, it will open up a thing called untitled. You can close it. So that's the source file. That is source. Click on this one, it will open a window that is called source. You can also activate the source by clicking on this one, adding a new file. It will open the source as well. Either way, you get source like this. So the interesting thing with the source is that you can type in a code, a script. So you can save the script. But if you are only using the console, which is this one, your code will not be saved. So that's the difference. You can type in here any code as well, code or expression or anything that you want, but it will not be saved. The thing that will be saved will be on the source. So that's the difference, right? So let me close this. Let me minimize it. So in the terminal and background jobs, you can see other things as well. So here in the environment, whenever you import variable, you declare a variable that will be saved in the environment. So that's this place. And files and plots and packages, we'll talk about them one by one. Okay. So just get familiar with it. In the meantime, those who have completed downloading and installing, can you please send me a message so we know that everyone is on the same page? Otherwise, few people will be able to follow. All right. In the meantime, some of you could again install it. Right. Let's go to the page. Now, after installing RStudio and RStudio interface, we will go with basic R syntax. This is important when we come to data visualization to understand what is R and what we can do with it first. So it's like the same thing that you do with Python. You can go ahead and type in things like, for example, if you type in on the console. So we are on the console right now, not on the source. So you can see this is the source and this is the console. So we are on the console. If you type an expression like this, it will give you an answer. Just type in anything that you like 1 plus 2, 123 plus 5, 445 divided by 2. Now you can also check if you plus 10 plus 5 divide by 2, whether it's going to be 12.5 or 7.5, you can decide. So let's enter. So you can see it's 12.5 because the division comes first and then the summation. Remember, board must. So if you type in the same thing with different ways, like 10 plus 5 divided by 2, now the brackets come first. So it's going to be 7.5, right? So likewise, you can actually prepare expressions in the way that you like. And if the screen is not visible to you, let me show you a way to fix it. You can go to Tools, Global Options, and you have the Appearance. Tools, Global Options, Appearance. Under Appearance, you can set the font size. So I'll set the font size larger for you to easily see this. But I usually have font size 10. So I'll set it to around font size 14. Now you should be able to see it better. This is help font size, editor font size. Let me set it to 14. Now you can see it better, right? Okay. And if you get overwhelmed with the numbers and the values on the console, you can easily delete them, remove them by pressing Control L. So it will clean your console. Control L, right? So you can go ahead and do different calculations and all these things. You will get syntax errors sometimes. You can see attempt to apply non-function error because I don't have a multiplication here. So you have to put them correctly. Unlike when you are writing on a piece of paper, if you have these brackets, you inherently identify them as multiplications. But in the case of R, you have to mention your operation clearly, right? So play with it a bit so you can get familiar with what R is and what you can do with it, a bit of an understanding of what you are capable of doing with it. So let's go to okay, there are a few other things as well. Okay, right. So I'll do one by one in the instructions. So 5 plus 3, that's addition, returns 8. 5 plus 3, and you can type in a comment. So this is how you type in a comment, the pound mark or the hash mark, not pound, hash mark. Type in and then you can say addition. So that will not be executed, it's a comment. So that's addition. Then 10 minus 4, that's subtraction. Will work, right? And then let's go to this third one, multiplication. You can just type in them and make sure that you put it as a comment. It will work. Otherwise, it will give you an error. And 9 divided by 3 for division. Let's do that as well. 9 divided by 3 for division. So this symbol will be the division. If you change it, what will happen? Let's see. It will not work here. In Python, it will give you a different answer. But here it's only 9 divided by 3 the other way around. Let me check whether it's working here. No. 2 to the power 3 for powers. So if you say 2 to the power 3, so this symbol is shift number 6. Shift number 6. So shift number 6 is for the powers. And of course, you have the functions like sqrt for the square root. Sqrt 12 will give you the square root of 12. Let's go with 16. It's 4. And if you put a negative value, let's see what will happen. So the values are not defined, right? Okay, let's see what is the square root of 0. 0, right? So those are the mathematical operations, and you can do all sort of mathematical operations that you are familiar with using R, the same way that you do with any other. Okay, so let's look at how we assign variables. Now you are familiar with Python, right? You know in Python, now if you want to clear this off, Control L will clean it. So if you want to assign variables in Python, what you did was you just type in x equals 3. That will assign the variable x with the value 3. If you enter this, you can see the values get stored here. Value is x, the number is 3, and you can see you don't need to declare variable, whether it's a numeric or a string or binary like you do in Java or C. You can go ahead and just type in a value with a variable, then it will automatically assign it with a numeric 56 bytes with number 3 here. So that's equal sign. But by convention, we don't use equal signs for variable assignment in R. Okay. Remember that we don't use this equal sign for variable assignments in R. Okay. We do a different symbol, that is the less sign and the dash. On your keyboard, the less sign will be next to M. You just type in shift less then Shift M will do this, and the dash. Next to 0, you can see dash. Just type in that, and that will be the variable assignment in R. That is by convention. You can very easily and safely use this one, but that's not the convention in R. In R, we use this. Okay. Remember that in R, we are using this sign, not this one. And you can get it easily by typing alt dash. Type in alt plus dash. That will give you this symbol. Alt dash will give you this symbol. So when you want to assign, let's say, x with a new value, let's say x5, x alt dash 5 will assign number 5 to x. So you can see new numeric value is defined with a different. You can also go ahead and define a new value, and you can see the value gets changed here. Okay. Right. Let's go with the next one. So once you assign a value, you have set x is equal to 5 or x is 5. Variable is assigned with number 5. You can go ahead and do any multiplications or arithmetic operations that you have done in previous case and assign a new variable with that. For example, if I set x to be 5 again, and x, you can see the x value is changing here, and I can go ahead and give a different value to y. Say y is alter dash y is equal to x times let's say 8 or something. Enter. Now you can see y is equal to 40. Whatever the value that you assign, the variable value and the variable name will be shown under this table. So you can see x is 5, y is 40. Now if I go ahead and do any arithmetic operation on x and y, x plus y, that will do the same, 45. So 5 plus 40, 45. Now please follow with me. What you can do is just type in things that I do here. That will be easy for you to follow. I'll give you some time to do this. Okay. So that's the assignment, and that is how we do mathematics with variables. So after assigning, variables appear in the environment pane in RStudio, that is this place. You can clean it. There's a little object, a little broom kind of a thing. You can click on, it's not kind of a thing, it's a broom actually, broom icon. Just click here and it will clean your environment. Now if you type in x plus y, it will not identify what it is because it doesn't know the values. Object X not found. So you can only use this if you have defined the values earlier. Otherwise, it will give you an error. So if you type in Y, object Y not found because it doesn't know the values. We have cleaned them from our environment. Okay. So that is the idea. If you have it, if you have the variable value, it will be available in the environment. Otherwise, it will be not accessible. Variable naming rules cannot start with a number. So you cannot start with a number like if you say 2x is equal to 2, unexpected symbol in 2x because the value, the variable name contains a number. You cannot have a number. And then you have can contain letters, numbers, dots, and underscores. In case sensitive, it is case sensitive. So if you say score and score, for example, if you say score is equal to 2 and say score minus 2, object score not found because capital S is not there. So if you want to get this to work, you have to set the correct capital sign, the correct letter, right? So it's case sensitive. Cannot use reserved words. Okay, there are reserved words like keywords. You have if else function, like for example, if you say if is equal to 3, you cannot use it because if is a statement that we use to say if. if statement. It's a keyword. So you cannot assign variables values to this. That's what it says. If else functions, kind of reserved words, cannot be used to declare variables. That's the idea. Okay. So I hope that part is clear. If you are okay with that, just put a thumbs up. So is it clear to you? The syntax, basic syntax, it's the same kind of what you do in Python. Just put a thumbs up here onto the chat. Right. Okay. Great. So that's the R syntax, basic R syntax. Now let's go with variables and types. Now it's important to understand what are the types of variables that we can use with R. You have basic R data types, numeric, as you could see. When you go ahead and assign a variable, it automatically says it's a numeric variable type. Now if I clean it, Control L, and let's say we can define a different variable like name is Sandun, for example. And now you can see name is Sandun, and Sandun is in with brackets or quotation marks. And if I go ahead and check, it's a character variable. So you have numeric variables, we have numbers, integers or decimals, character, text strings, and logical Boolean values. Now if I say answer is yes, let's say true, answer is true. Because the answer is not defined. Right, we'll come for the Boolean variables when we do it, but the Boolean values are true or false. So these are logical values. Then you have factor values. Those are categorical variables with levels like ordinal values that you are familiar with. Yes, sorry, high, low, mid, high, mid, low. And then you have like 1, 2, 3, 4 in the Likert charts. Those are logical variables and then factor variables. So you have numeric, character, logical, and factor. Those are the basic R data types. Then you have data structures. So data structures are constructs of data types. So you have vector data, that is one-dimensional collection of elements. The elements should be same type. And then you have data frames, like in, I don't think you have done Python data frames if you haven't done pandas. So data frame is a table-like structure. Columns can be different types. So columns can be different, but a single column should contain the same type of data. It's a collection of data. uh, if you want to imagine it, it's a collection of vectors. So in a data frame, like in your Excel sheet, you can have names, and on the names column, you should only have names. And then if you have age, on the age column, you should only have numeric values age. You cannot, mismatch the type. Columns can be different types here, but in a column, you should have the same element type, okay, like in the vector. So list, flexible container for different types and structures. So in a list, you can put like multiple things like your bag, like for the girls, you have these makeup items and all these things in the bag, like all sort of things, right? For boys, we have only few things. So in a bag, you can contain different types of structures or data types. You can put many things in the list. In the matrix is different. In the matrix, you have two-dimensional array and it should be same type. Okay. Whatever the value that you put in, it should be the same type. So that's what you need to remember. So if you want to understand what R does is, you have basic 4 R data types: numeric, character, logical, and factor. So then you construct data structures using data types. So in the vectors, you have to have same type data. It's a one-dimensional collection of elements. And then for the data frames, you have multiple columns, but different columns can be there, but one particular column should contain only one particular type of element. Then you have a list where you can put multiple types of data in the same structure. And then you have matrix, that is a two-dimensional array like numbers, so it should be the same type. You cannot have different types of data in the matrix. That's the idea. Right. Let's go ahead and do the declaration. So if you say name Sadun, you know the name Sadun will appear. Scores. Let's go ahead and type in scores. And now I'm going to create, this is called a vector creation. So this is a vector. Vector is a collection. So remember the C is there. So when we declare a vector in R, you have to have this C. It says collection. So it's a collection of values 4 comma 3 2 comma 3 whatever. So you can see uh, it's a numeric vector 1 2 3 4 2 3, and you can see it's a numeric vector. Now if I go ahead and say the same thing, now let me change this to capital S, and instead of 4 2 3, let me put 4. Now you can easily do this, shift select and type in the quotation mark. It will not remove the value, instead it will put the quotation marks around the selection, right? If I select shift and put the quotation marks and enter, you will get another vector, but this vector will be characters. Now you can see it's a character vector. Scores is a character vector, not a numerical vector. The difference is that I have mentioned the vector contains characters instead of numbers. Okay, so remember that if you are going to create a collection, and in your collection, for example, if it looks like this, it will not be a vector. Remember, vector can only have the same type of value. So if I remove this quotation mark, and now you would see scores are there, but now if I go ahead and check this scores, this capital S scores, it will be character still, because you have two values with characters. Now if I go ahead and remove let's say this, it will also be still character, because 4 is defined as a character. Now if I say something like this, here if I say Nandun, and you can see it's a character, and now Sadun is there. 2 3, they are considered to be characters, they are not numbers. Now if I do it in a different way, let's say I put Sadun in the first case like this without the quotation marks, you should get an error, because Sadun now should be identified as a number, not as a character. And remember, when we define a character, we need to put it inside the quotation marks. But in this case, I haven't put anything, any quotation mark. Because of that, now R is trying to create a collection of numbers, but Sadun, it doesn't know what is the number of Sadun, so it gives you an error. So if you need to define it, you can define Sadun to be like 3, or let's say 4 or something. And now if you declare the collection of values as a vector like this, then you will get an answer, because now Sadun is a number. Sadun is 4, right? So that you have, these are some tricky things that you have to understand when you are developing the codes. Sometimes you get an error, but to understand the error, you need to have an idea of what this is, right? Even if you are using ChatGPT to create codes, you need to understand what is the code and how the code is defined, right? So that is a collection of values or a vector. So the next one is a logical assignment. So you can say past or score, like so just say true, capital true, and it will be a Boolean value. You can just go ahead and check, it's a logical value, right? So now let me show you an interesting thing. Now this is true, right? True is a Boolean statement, and false is a Boolean statement as well, capital, right? So that's a Boolean statement. Now, instead of typing false, if I type like 3 less than 2, 3 less than 2, is it true or false? If I type in 3 less than 2, is it true or false? I want an answer. If I say 3 less than 2, is it true or false? It's false. right? So it will execute as false. So if you type in 3 less than 2, that's a false Boolean value. It's a false statement. So if you assign this inside the brackets, if you do this, then past will be assigned with false, not 3 less than 2 or anything. It's just false. Remember that Boolean values only have a true or a false state. So if you do this statement like, if you do it like this, for example, now 2 times 2 is 4 and it is greater than 3 years. So it's going to be a true. Okay. So it doesn't matter what you have in the expression, unless or otherwise it is executed to be true or false. You cannot assign it as a Boolean value. That's the first thing. If you think of Boolean values, you can only have two states, either true or false. Remember that. So you can do any mathematics, anything, but need to understand that the execution for a inequality or any logical statement will be either false or true. So when you assign it, it will be false or true. So now if I create a vector with the Boolean values, for example, I'm going to create a collection of Boolean values, 3 less than 2, 4 greater than 2, let's say 5 less than 6 minus 2 something. Now you can see I have statements inside this one. It's a statement vector with a collection of statements, and I get a past logical vector. So it's a logical vector. If I type in past now, I will get false, true, false. Now, if you are a computer, you should imagine this like false is 0, true 1, false is 0. It's a 0, 1, 0 vector. Okay, just digest that idea. So if you execute this collection, it will be 0, 1, 0 vector. Okay, we to make it easy for us, we will be seeing it as false, true, false, 0, 1, 0. So if you change this statement, for example, if this becomes like 1, okay, now you get a vector of 0, 0, 0. Right? So let's go back to your statistics knowledge. You have two options here, two options here, and two options here. It can be either 0 or 1, 0 or 1, or 0 or 1, which means you have 8 possible combinations, 2 times 2 times 2, 8 possible combinations, 8 possible vectors. If you are going with this true or false statements, it can be false, 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 true. False. You know the matrix. So you can, so that's the beauty of this. You can have different operations, different answers, and it will give you the vectors and the matrices, so the data frames accordingly. Now let's go ahead and go with the next part. So that's the variables and types. Let's go with installing and loading packages. Right. Now you have learned packages in Python, have you? So if you have learned Python packages, can you explain to me what is a Python package? Can you send me a message, chat message? What is a Python package? What do you mean by a Python package? Okay, good. Written function. Any other idea what is a Python package? Written function. A collection of modules organized in directories. Okay, good. Straight out of a textbook answer. Any any other answer? think about simple ways to explain this. What is a package? Way to organize. Okay, good. Right. You have a lot of ideas, written function, collection of modules organized in directories, way to organize. So let's have a mental model of what is a package. Now let's see, we did all these things, right? So whenever we want to repeat this one, we have to do it again, right? Imagine that you did your Power BI work. So in the Power BI visualizations, what we did was we took Power BI and we created a script query. So in the advanced query, you have the source, you have the data types, and then you organize the rows, maybe set the first row as headers, and then you do the splitting. You did, if you have missing values, you address that. You did lot of things in Power BI, right? So that that particular workflow is saved in the advanced query. So as I said, if you copy the advanced query and send it to someone else, they can replicate the same thing. So that is the beauty of it. Now, packages are like that. Now, instead of now, what we did was we just created the script in Power BI and we have to always send the script to anyone else. Now, instead of, imagine if you have like 500, 600, 700, 1000, 1500 kind of lines. Very, very difficult to copy paste again and again, right? It's very difficult. If you have a very streamlined workflow in a large company with multiple types of data from a data lake, you have like thousands of lines. You need to copy paste every time you are trying to do this. Or if the organization is trying to hire new people or follow the same work procedure, you have to again and again copy paste thousands of lines, which is to do manually is a very troublesome thing. It takes a lot of time from the organization and it takes money and effort and can go wrong as well. If you are copy pasting 1,000 lines, there's a chance that one comma might be missing. Or during the copy pasting, maybe you type in something in between that you cannot find. So because it's very difficult to navigate in such a large set of lines. So to avoid this one, we have packages. So what packages do is you can organize your workflow and connect different workflows. For example, let's say that you are looking at maybe preparing a meal in the kitchen. So if you have a way to, let's say you have a blender. So the blender, what blender does is you can put things into the blender and you can chop them or you can crush them and make a juice out of it. So it's an operation that you can do with the blender. You take whatever you have, you cut the pieces or the vegetables, clean them, and make you if you want to make a smoothie, you put the things and then you chop it or create this juice out of it, right? That's an operation done by the blender. Now if you are creating let's say a chutney or a chapati with something to eat with the chapati, and if you have a whole collection of food to prepare, then blender is part of that process. Blender will be there, and whenever you need to chop something, you put it in the blender and chop it. So the packages are like that. You have blenders, you have rice cookers, you have the gas cooker and the electric oven, fridge. So you have all sort of things in the kitchen. The packages are like that. In order to do something, you have to organize the packages in the way that you want them. So if you are creating let's say smoothie, if you want milk to be added in the smoothie, if you need the fruits to be chopped, you need the let's say you need a nice glass, and you need ice cubes if you want to crush ice cubes with the fruits. So you need all these things, and you don't need, if you are going to have a smoothie, you don't need let's say um, oven, for example. If you want, I mean there can be recipes in which you need the oven to create a smoothie, that's a different scenario. But I'm asking if it is a typical smoothie, just the milk and the fruit juices and some, if you are adding some vegetable type of things as well, you only need that, right? Those things. So you don't need the oven. So even if you have the oven in your kitchen, you will be taking only the things that you need, right? So the packages are like that. You can have packages in the repository in somewhere else, like at your home, you have other things as well. But you don't take everything when you want to prepare a meal. You will be taking the things that you need only for that meal to organize things in a way that you want. Packages are like that. So let's read about packages. Now in the CRAN repository, if you go to CRAN repository, it's actually maintained by scientists and people who are working with R. A lot of people are working with R. Actually, if you can read about this, if you are interested in, you can read about it. Now, if you go to the CRAN project, rproject.org, you can see there are few things to the left hand side. CRAN mirrors what is new, search CRAN team. So if you click on CRAN team, you find people who are working, like Benjamin Altman. A lot of people are in this area. Like some of them are actually doing it for free because they love doing it. So you have a lot of people from all around the world. So we need to acknowledge them, their hard work and effort. And then you have at the bottom, you have software, R sources, R binaries, R packages, and then you have this packages. If you click on packages, you would see table of available packages sorted by date of publication. If you click on this one, you can see all the new packages created here it is in the descending order 2025 12th July, that's I think yes today itself. You can see how many packages have been created and according to the date of creation. You can see these are called packages. So you can create a package in house, and if they are in the standards, if the R community accepts this one, your package, then it will be taken to the repository. So this is the repository. It's available throughout the world. So you can see a lot of things are created. The scientists are creating these things every day. So table of available packages, table sorted by name. So typically these are all the available packages, but we will not use all of them. Now, for example, if you are in financial analysis area, you would need some sort of packages. If you are in physics, if you are in engineering, you will need some sort of packages. So if you are in water quality science kind of area, like blood testing, those things, DNAs, bioinformatics, you will need some type of packages. So there are a lot of packages developed by different scientists, different groups. You can download them, and instead of copy pasting all the scripts like we did in Power BI, you can paste this in copy paste things in your base R where you have your R. So instead of the scripts, thousands of scripts, you have this. When you run this install.packages, what it does is when you run it, it will go to the package name, and downloading means it just copy paste whatever the thing here they are in the repository in your machine, and you have a in-house package. The package will be saved in your computer. You can use that package. So that's the whole idea of packages. You can create your own package, like if you become an expert in R, or no, you don't need to be a very good expert in R, but if you are aware of R and if you want to create a package for your company, for your personal project, or for whatever the reason that you need it for, you can create it and keep it in your local repository as well. Unlike in the case of, like, even in Power BI, if you have a nice workflow, you have the advanced script, you can keep it, and whenever you want it, you can use it, reuse it, just changes also other things, and you can use it. So likewise in R also, you create your own package, you can keep it as well. Okay, let's go ahead and install our first package. Now I have installed my package tidyverse on my machine. So I will not run it, but let's say Control L to clean everything. Just on the console, type in install.packages tidyverse and enter this. You can see R tools is required to build our package, but it's not currently installed. Please download and install. Don't need to worry about it. So you can see trying URL package tidyverse successfully unpacked and installed. So you can go ahead and do that as well. Can you do it? Once you do it, just let me know whether you could install it. Tidyverse. Install this. Once you are able to install it, just let me know in the chat. Send the message to everyone so others also see that others are doing it. Okay, some of you were able to do this and install Tidyverse. Right. So once you have installed Tidyverse, let's go ahead and see what Tidyverse is, because it's our first time, and in the first time it's always an interesting thing to see what this is. So Tidyverse should be somewhere on T. So let's Control F and V. Tidyverse here. So this is Tidyverse. Easily install and load the Tidyverse. So let's click on this and see what Tidyverse is. The Tidyverse is a set of packages. It's a set of packages. I told you in the kitchen, you have your fridge, you have your blender, you have your oven, you have your gas cooker, you have your rice cooker. All these things are there. So it's like a set of things, again, a set of things. So you don't define what a fridge is, right? Fridge is also a collection of other things as well. A blender is a collection of a motor and other things. So you have a set of packages creating a package. So it's like a whole thing. So Tidyverse is a set of packages that work in harmony because they share common data representation and API design. This package is designed to make it easy to install and load multiple Tidyverse packages in a single step, like creating your own kitchen. Okay. So in the kitchen also, once you create the kitchen, sometimes you don't have all the things, right? Sometimes you have a set of things that you need. So like Tidyverse, you have a set of packages that would be useful for you. Now you have this thing called depends. Depends. This is important. I'm just explaining it for the first time and maybe for the last time for you to have a good idea. So the version, this version means the package version, the collection of the packages, its version, it's 2.0.0. Depends means what is the R language that can be used to run this thing. So it should be above 3.3. If you have an older version, you will not be able to use this tidyverse package. If it is less than 3.3 version, you cannot use it. So that's what it says. So if you get dependency errors or some errors saying that the package is incompatible or things like that, you have to first check whether your R language version is correct. It should be 3.3 or above. Then you have imports. What it does is it will import these other packages. You can see DPLYR, Forecast, ggplot2, Google Drive. Some other packages are involved with this Tidyverse. So when you install it, it will import these packages as well, right? And then suggest these things which are also needed. Then when it was last published and the DOI, you can click on this one and it will be here. So that's what I said, the scientists are building on this one, because if you are let's say you are a scientist or your group is developing new packages, you get a DOI, digital object identifier. So your group gets to have this forever, like your group will be there. And this Hadley Wickham is a very renowned scientist, right? He was he was if you search him, Hadley Wickham was a founding member of one of the packages there, and he's in New Zealand. His student is Rob Heidman, Wickham and Heidman. Like Heidman was in Monash, so you have a lot of things. He's a very famous guy in this area. So Hadley Wickham is the guy who is maintaining this, right? and then you have bug reports, licensing, and other things. So what you need to remember is you have a package source, this star.gz as well. Now, if you are looking to develop this in a different way, if you want to develop as a custom package in your laboratory, or if you want it to do it in personal use, you can download this star.gz. Why am I telling this? Let's say by any means, if you don't have internet connection, or your firewalls are blocked or some issues are there, you can safely go to the package that you want and download this. If it is in Windows, you can download the binaries, or if you are looking at the package source, you can download the tar file. You can download them and install them on your RStudio as well, right? Maybe at the moment it is not necessary for you, but there may be a time that you need, maybe, I don't know, in the future, if you want to use it and you don't get the chance to install it or something, you can keep this base packages and download the zip files and install them as well. So that's just for your understanding, because that may be useful in, I don't know when, but it can be useful. Okay, so this is how a package is stored and where the packages are. It's very easy and very neat. It's not everywhere, it's there on the CRAN project. Okay, so we have installed the tidyverse. Now let's go ahead and do our next thing. Once you install the package tidyverse, you can obviously take it. So library tidyverse. So you can see the packages here, or the packages that you can install. You can tick it and install from here as well, instead of typing in installer packages. That's also possible. But let's go ahead and run this. So I'm going to say library tidyverse. The tidyverse is the package that we have installed, and I'm typing in library tidyverse so I can bring it. In the kitchen, you just want to organize it so that you can use it, right? So I'm going to bring it to my table. So when you type in library tidyverse, it will load the package. You can see what it does. Attaching core tidyverse packages. Package was built under R version 4.5.1. So you can see it's now there, right? The packages have been loaded. Now, if you go ahead and check the under the packages, if you go to tidyverse, now you can see there's a tick. Tidyverse is there. It's installed. That's what it says, right? So in my environment, now I have tidyverse. I can use whatever the codes inside tidyverse. That's what it says. If you want to use tidyverse, you need to load it. Library tidyverse will load it. And check the loaded packages as well. So you can search it. If you search, you can see all the packages that were loaded. So you have global, that those are loaded when you just open RStudio. And now you have also loaded tidyverse as well. And if you remember, when you talk about tidyverse, the tidyverse contains other packages like ggplot2 and other things as well, so they were also loaded. That's what it says. Right, done. So located in bottom right panel, packages tab. Checkbox will say package is currently loaded. As I showed you, click package name to view documentation, install button for the packages. So use the question mark function name syntax to pull up documentation. Now, if you type in like question mark tidyverse, it will give you the help package here. Okay, so if you find any issues, don't rush into ChatGPT first. Or no, don't do that for the first part. Just learn it in the hard way for the first 2-3 months or weeks. Then go to ChatGPT. That's fine. Learning from ChatGPT is totally fine. I don't mind. But the thing is, you have to first do it in the hard way for the first 2-3 weeks. Then only you will be able to understand the responses. So learn it from here. Okay, right. That's about how we install and load packages. So we have installed our RStudio basic R syntax and variable and types, installing and loading packages. Now let's go ahead and look at data import. So we can import data like we did in the, so we can create data in different ways. Remember, we can create it as a vector, see, a collection of values, and we can declare values as with the alter dash. You can just say equal as well, but we don't use it. So we can define values in that manner. Now we will be importing data. Data import, learning objectives, reading data from files like CSV and Excel, because these are the type of data that we usually find. Then we have to handle missing data, filtering data subsets, creating new variables, recording values, all the things that we did with Power BI. We will work with student evaluations.csv, the file that you have downloaded. So without anything, like let's say the initial part was an introduction. So when you are trying to use R and RStudio for the first time, let me clean the other variables as well from here. Yes, clean them. So first thing, whenever you start working with R, right? First thing you have to do is type on the console get WD with brackets, get WD brackets and enter. Do that, get WD and put this brackets, right? You would see the path you are working right now, where your working directory is. So get WD, I'm on users admin documents, right? So this is where I am. Now, if I am going to work here, every time I am going to use data files or other things, I have to give a very lengthy name for the file path, right? To avoid that, we will set our working directory to the place where we have our data. For every project, for every time that you do this, make sure that you set your working directory as the first command to the place where you are working. So I'm going to set my working directory. Now this is my get working directory where I am right now. So I need to set my working directory to the data file that I have kept this particular thing. So where did I download this data? So I have downloaded my student evaluation data to this folder. This is the folder data visualization. This is where my data is currently located. So I'm going to copy this one, copy. I'm going to close this. So now I'm going to set my working directory. Go to set working directory, set WD. Easy to remember. Get WD, get working directory, set WD, set working directory. So I'm going to set my working directory. Inside this, you need to set your working directory. So my working directory is this one, right? So if I type like this and enter, I will get an error because R will not identify the backslash, this thing. There would be an issue. So you need to set that thing correctly. You need to say this, change it to forward slash. Now you can see the set working directory has worked. And now if I say get working directory where I'm working, I'll get my working directory as is. Please set it to the place where you have downloaded the data and just put a thumbs up or something so I know you have done it. Let's avoid having multiple thumbs up. So I just ask you done and react to my message. Just put a thumbs up. So no, I know most of you were able to do it. So far only two. Please go ahead and do it. 3, 4. Only 2, 3, 4. Okay. Right. So we have set our working directory to the folder we have downloaded our data. That's the first thing you have to do to organize things easily. There can be many other ways, but this is very neat. You know where you are, getting your working directory and setting your working directory accordingly. Right. Our instructions say we will now read the CSV file student evaluation.csv. So the command for reading the CSV is read.csv. Easy to remember. So I'm going to get evaluation data. Evaluation data will be assigned with the CSV data found in student evaluation.csv. I'm going to copy this one and run it. Now you can see, similar to the previous case, on my environment, I can see evaluation data. Now it's a data frame. Evaluation data, it's eval data. That's the name I have given, eval data. It's a data frame. If you go to that place, you can see it's a data frame. And you can see the number of observations and number of variables. So the number of variables are the columns. Observations are the records, the rows. So 30 rows and 12 columns. So if I click on this eval data, just click on this, you can see the value gets opened up. The CSV kind of a view can be seen. So it's also, you can activate this by typing in view eval data. You will get this table. So similar to an Excel sheet, you would see 30 entries, 12 total columns, showing 1 to how many values are also showing what are the number of columns. You can see this, right? So were you able to do it? You import the CSV file and you assign that to evaluation data. And when you view evaluation data, you can see this as similar to a CSV file. Done? Right? Hope you were able to do it. So we have the student ID, gender, course, some values, and then the overall. Inside that also you can see NA. NA means missing values. Not available. NA, missing values are there. Right. Okay. Now we need to read the Excel file as well. So we will read it using the, if you just type in this one, let's go ahead and type read Excel. It will give you an error. Let me close this one for you. If you type in eval data, read Excel and the Excel file that we downloaded, it will give you an error. In read Excel could not find function read Excel because it's an additional package. So to read Excel, they have created a new package, and since we haven't loaded that package, it says you cannot find how to do the read Excel thing. So we need to first of all load the library read Excel. So we load the library read Excel and enter. So the library will be loaded. Now if I type in read Excel, where is the student evaluation? Should be student survey. It's not evaluation, it should be student survey. The name had an issue. Sorry. Student survey, not evaluations. Survey. Now you can see uh, evaluation data gets updated with the student Excel file. Make sure that you name it correctly, right? Okay. So what happens here is evaluation data. I just rename it. It should be student survey, not evaluations. Just type in that name, then it will work. Right. So we have this one. So if I click on this one, you can see what is there on the Excel file. It's different to the CSV file. Okay. So done. Control L will clear this. Let's go to the next part. Initial data exploration. So I like to have the CSV file. So let me have my CSV file first. I'll just keep the CSV file with me. So the evaluation data contains the CSV file. Now, you can click on this one and of course, initially check the values, which is a very handy way to do it. And it's easy. You can click on it and or type in view evaluation data, eval data, the name that you used, and it will show you that table view. It's easy to do, right? But if you want to do it in like in a programming way, you can type in head and head of eval data. You can see if you type in eval data inside the head command, it will show you the first 6 records of eval data. Now, I think you can change the number here. If you type comma 10, it will show you the first 10 records, 10 rows of your evaluation data, right? So I'll go ahead with just first 6. So you can look at it. Unlike in the case of looking at it like a CSV, you can see it on the console head evaluation data. And also, if you say str, examines structure and data type. That's str stands for structure. So if you say str and say eval data, you can see what are the type of data. Remember when we first learned about the data structures, the data frames can contain different types of data, but single column should have single type of data. So student ID here it is integer, which is wrong. We have to change it. But for the gender, you have character. It can be a Boolean value, male or female. Then you have course. It's a character type. Then you have integer type for overall as well, and the pre-score. So you have whatever the this type can be different. We can change it to a different type, but a single column will contain only single type of data. So data frame contains values in the same type values, right? So you know the column names and you can see the value. So you can check that with the structure evaluation data. So two commands to remember: head and structure. Then we have the summary statistics, summary of evaluation data. If you just type in summary eval data, you get all the statistics for the respective columns. Of course, the statistics will vary because we haven't set the statistics properly, the type of data yet. Student ID should be not an integer value, it should be a label value. So it should be a character value or a factor value should be there for the other values as well. So we haven't set it as of yet, but you can, if you have the data properly, then just by typing in summary, you'll get all the values, the summary of the values for the respective columns, statistical summaries. Okay. So let me remove it. So head, structure, summary. This is the summary. Let's go to the next part. So first we now have an idea to import data and check its head, structure, and the summary. 3 things. Let's go with the handling missing data part. We'll talk about handling missing data in the coming lecture, the part of the lecture as well. But it's good to follow this structure and get a good idea initially. So ISNA is like very easy to remember. Remember, the missing values were identified like NAs, not available, not available. These are just English names, remember it, not available. So what we really need to do is to check whether they are there. So is na is checking not available or missing values. Very easy to remember. Is not available. Is not available. Is na will give you that. So if you have, we can now, if you take a look at eval data, if you type in eval data, which is the data that we have assigned with our CSV file, if you type in eval data and press the dollar mark, very simple, eval data, and then press the tab, it will give you the variable, and then type in the dollar mark, then it will allow you to access its vectors or its columns. The dollar mark will allow you to access its columns. So if I say evaluation data Q1, enter, it will give you the values in that particular column. Like in Power BI, the column, the value of the column. So eval dollar mark, data frame name, and the dollar mark. That's how you access the values, right? Now you have the accessibility, and then you put isna in front of it. So isna is giving me the option to check what are the missing values, right? So what I'm going to do is I'm going to say is not available, isna, and I get a small bracket. Inside the bracket, I need to put the value, put the vector inside this isna vector, or the value that I need to check with. So what I'm going to do is now I'm going to put evaluation data, that's the data frame, and I'm going to access the column that I need to check. I need to check Q1. Now if I enter this one, remember isna is asking for a logical answer. If it is not available, it should be true. If it is available, it should be false, right? Because it's a logical statement. It can be either true or false. When I enter this, I'll get the same thing. Remember, I created a Boolean vector when I started the lecture. So we get the same thing, 1010 kind of a thing, 000. So when you see a not available part, it will give you true. So here, this one is not available, NA. So you can see that is 1, 2, 3, 4, 5, 6, 7, 8, 9. Ninth value is not available. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Ninth value is true. So when I check ISNA, whether it's not available, I get the ninth value to be true, which is true because it's not available. Okay, that's how you check it. ISNA not available. And now count, we can now remember ISNA is not giving us any numerical value. It is giving us a Boolean vector. It's giving us false or true vector. So if I count the number of false and count the number of true, I can get an idea about how many missing values are there, how many true, how many non-missing values are there. I mean, how many values are there. So I can simply get the sum of things. So if I type in sum, I can get the summation of a vector. If it is a numerical or whatever the vector, it will give me the sum depending on the type of vector that I put in. So if I put a character vector inside it, it will count the number of values there. So if I say sum is na and enter the eval data dollar mark Q1, now I am asking, first of all, go to the eval data column, Q1 column, and then check whether there are any missing values. And I'm asking, give me the sum of it. So if I enter this, you can get the summation of the true values. So I get there are two missing values. Okay. That's what it does. So if you give sum, it will count the true value sum. Now there are some tricks to do this, like it's not working here. So you can get the summation as like this. Now you can count missing values in all columns, missing values in all columns. Instead of giving one column, like if I give, for example, if I can access one by one by one, but I don't need to access like that. If you need to get the entire thing, uh, you just count the column sums. So now what it does is it will sum the number of missing values and give you the value in front of each. Now if I just type in sum, what will happen? Let's check. I just type in sum. It will give you all the missing values because it's just giving the sum of the true. Call sums, call sums will give you, it's not call sums, it's not that, column sums. So that's why it says call, capital S should be here, call sums, and it will give you the values of the true missing values in front of this. Okay, checking on something. Okay, I got a different typo here. Just bear with me. Okay, there was an error on my keyboard. Right. Yeah, that's it. So you get here. Column sums give you the column summation of the values. Col sums will give you that. Right. Now you can remove the values, omit, NA omit, and give the data. So it will remove those values. So if you go to something like that, not available, omit, and let's say eval data and give Q1, and it will give you that. Okay. If you just type in the data, eval data, it will give you values, omitting all the values that are not available. That's what it is. So for example, if I give NA omit data and give new data, assign it, and our new data will contain only 19 observations because it contains no NA values. I have removed all the NA values, which can be bit tricky because let's say you have some important data, then you have to keep them. So in that case, this may be not needed or can be changed. But na.omit will omit the values that contains any null value, any not available value. Filter specific rows. So this is what I was looking for. Filter eval data. Now if I, let's say is na, right? Is.na and eval data. Let's assess the first one. So it will give you this one. Now, if I go ahead and type this in front of it, what do you see? Can you tell me what is the difference between these two commands? Send me a message. What is the difference between these two commands? The exclamation mark will give you the not logic. So if you, for example, now if you go ahead and say sum, if you give the sum is now level eval data, say column sums, for example, col sums. It will give you the columns with not available values, right? But if I type in call sums and in front of it, if I put a negation, that is the exclamation mark, it will give you the values, not the not available values. So that is the difference. So this is negation, logically not. So if you say 3 greater than 2, it will be 4. If it be true, 3 greater than 2, yes. But if we say not, it be false, which means the negation of it, not of this. So not will be that. So if you are getting any type of a Boolean vector, if you put the exclamation mark in front of it, then it will change the signs. So it will be the not logic of it. You put things in the not gate. So having this in mind, if you type this one, filter eval data is na, which is this one. Filter, filter is the command filter. So if you type in filter, you will see what it is. Here you need to first give the data frame. Evaluation data is our data frame, and give the logic vector to filter. So what we are referring here is I'm asking it to filter the values in the data frame eval data where the Q1 values are not null. So that's what I want to do. So in order to do that, what I'm giving the instructions are filter. So the data comes from eval data, right? And I'm asking it to I'm giving it the vector is.na and eval data first Q1, right? Eval data Q1. And if I give you this, if I give this one, what it will do is it will give me all the values where Q1 values are missing. So if I enter it, you can see where the Q1 values are missing. So Q1 values are missing in these two records. But let's say I want the values that are there, not the values that are missing. So I just give the not logic. And that will give me the table in which, or the data frame in which the Q1 values are present, not missing. Okay. So if you want to organize it in that way, for example, you are doing an analysis on specifically focusing on the Q1 values here, then you can just take the values that are present and omit the values are missing that are missing. So that's what it does. You give the vector that contains the true, and the filter will do the rest. So what filter does is you give the filter and give a condition here. That's what it does. So the condition is a Boolean vector or a Boolean statement. So the statement is this. So we give simply we give a vector with Boolean values for filter to work. That's what we do. All right. So if you, for example, if you go ahead and give a different value, like for example, filter eval data instead of is now, let's say eval data is Q1 is greater than 4, it will do the same kind of filtration, but instead of that previous isna is the vector that we use, this is the Boolean vector. Now the Boolean vector is evaluation data Q4, anything that is greater than 4. I hope you understand what I'm saying. So if I say equal to 4, you can filter data like that. Okay. Am I clear? So if I'm clear, just put a thumbs up. So whatever the condition that you give after the data frame will be executed and filtered. The condition will be filtered. Filter is a condition, right? We filter based on a condition. So for example, if I want to extract the course value, say course, filter data course, and the course should be equal to the course A, then I can filter out course A values. So that's what it does. Any condition that you plug it in will be filtered. That's what filter command does. Okay. Right. Then there is another thing called impute, means with other values. So we'll talk about this when we do the other part of the lecture. So we'll not do it here with imputing. Impute will replace the values. So if you type in impute, you can see what it does. Impute will be available. We'll talk about it when we do. So filtering rows, mutating and recording, data type conversions, clean data ready. So we will talk about these things with extensive details. So we'll start with some logic. So I told you that filter works with the logic, and I've given you some examples. So the same thing, I need to repeat the things here, but I'll show you some additional things. So remember this, whenever you use filter, whenever you use filter, what you do is giving a condition after the filter command. So for example, you can type in filter and then you give the data frame and then the condition, the logical condition. It's a logical statement. So this condition can be x greater than less than 3 or whatever. So this condition is what we have given here. So the condition can be easily assessed if you have the eval data. Eval data is like when you, so the filter command is available in dplyr. You can access it like data frame, dollar mark, and the column name, or you can just type in the column name as well, since we have loaded the dplyr package. So if you, for example, type in female data, since evaluation data is there, now if you type in female data will be the screen values where gender is F. F is female, so gender F will be there. So that's what it does. Okay. So then actually there are some complex logics like high ratings, like if you say, and you can combine logics, right? For example, logical statements can be combined. So if you have, let's say 3 less than 2 and 4 greater than 4, sorry, greater than 5, it is false because this is 0 is false. This is false, false and false, it will be false. But if I type in 4 less than, this will also be false because this is false. This is true, but false and true will be false. So if I type in and two and statements, so you get true. So that's how and logic works, right? So you can type in any type of logic here. You can also create a logical construct like logical construct is this. It's just a Boolean assignment, nothing else. Logical construct will be that. So if you say logical construct will be this one, gender equal F. So let's say this is the logical construct. But here you need to make sure that you type in the proper thing, okay? That is eval data gender. Otherwise, it will not know what is gender equals eval data gender. So this will create this logical construct. And now without any issue, you can type in logical construct in the filter command here. You can type in logical construct and it will do the same thing. So when you are writing a function or you do the analysis, you can create logical construct as a separate thing and you can just change the logical construct accordingly. Like for example, in my, say I want a different logical construct. So the logical construct can be this one, cos A equals cos A and overall feedback is greater than this. So I can create that logical construct here. That is my logical construct. Okay, course, because the course has to be coming from evaluation data. This one. It doesn't know what is course, so that's why. Overall, that should be there. Now it created the logical construct. Now if I go ahead and use the logical construct and change it to maybe high score, whatever that's there. Now it gives me the high score. So you can be creative, and based on the creation that you do, you can organize this pretty neatly. So that's the beauty of it. And you can develop multiple logical operations, logical constructs, and you can do that. So that's about filtering. We call it subsetting. Filtering, what filtering does is you select rows. That's filtering. Mutating the records, so you can mutate again. In this case, you can mutate. When you say mutate the evaluation data, I think you need the dplyr package here as well. Not sure whether this is going to work. Let's see. It works. So what it does is, now in the evaluation data, if the average rating is this, you can mutate. The mutate will automatically plug in the missing values with the whatever the value that you give here. So it's a value and it will put values in all these cases. For example, let me now let me go ahead and check any now for the evaluation data average rating. I go with, you can see average rating there. It adds a new column with the average of the values, average rating. The missing values are missing because it doesn't have values here. That's what it does. So you have missing values here. So you can't create an average value for the missing values. That's why you have a missing value column. So mutate will add a column and you can create new things. Right. So data type conversions as numeric character factor date. We will learn about it in the next lecture. So next lecture will be starting from here. We'll talk about mutating the records and data type conversions, clean data and ready data to processing. And then we will start the lecture data visualization part using R. Here, I'll give you a briefing about what we'll be doing in the next lecture. So there would be two lecture slides. The first one is the visualization, the grammar of graphics. So what do you mean by, we'll do the remaining part, of course. Then we'll start with grammar of graphics. What is grammar of graphics? So grammar of graphics is actually the way R works. So this is the research paper that defines the grammar of graphics. It is Wickham's paper, Hadley Wickham's. You remember who Hadley Wickham is? I introduced you there. So Hadley Wickham has developed a mechanism, a way to visualize data in R. We call it grammar of graphics. So when we read or write English language, we know what is grammar. Grammar organizes the language in that manner. So grammar of graphics is how we organize the graphics. Right, so we learn about grammar of graphics, what are the layers and what are the things available in the layer in the when we organize grammar graphics in the grammar structure. And then data wrangling, we did some part of data wrangling today as well, how to subset data and filter data. We talk about what is the meaning of data wrangling, how we organize data and data wrangling. So data management using R and data wrangling using R. We can cover this in one lecture if we can follow quickly, right? So we will try to do this. So please make sure that you follow the first two things in this website, the R for social thing. The first part, of course, you have already done it. I don't think you need it, but this data import and cleaning and preparation part, the module two, please try to follow it. Try to do whatever you like. It doesn't matter. Go to ChatGPT and find ways in which you can change and understand it. Always have a clear understanding whenever you learn programming or scripting. Try to understand it first in the simple, most easy and neat way. Then go scaffolding on it. Don't try to learn complex things first. It will complicate things. Just understand it simply. Okay, if it is filter, you put the data frame and then the logic. If it is mutate, you put the data frame and the additional column that you want to create. Additional column. If it is missing, if there are missing values, additional column will contain missing value. Very simple statements, right? So if you need to find the null values, is dot na is mean it will give a logical one, and you get that logic to filter. So remember it like that. It's easy for you to remember. Like we only did like 10 statements as such. So if you remember those 10 things, then build on that next time, build on that next time. After 2 3 weeks you'll be able to fully understand, and then scaffold. You can go for complex things from there. Okay, so we will call it a day for today. And before I wind up the session, I want to get your opinion about, do you understand what we did today, and do you think it's useful and you get an idea that you can continue? Uh, just send me a message. Was it helpful and you got something? While you send a message, I want to let you know something as well. For your uh, practicum session, Dr. Mark will have a session, a small chat with you. Anyone who is interested in working with Dr. Mark in the analytics practicum, just keep that in mind. He will share with you some uh, meeting link, and you can meet him in the evening. So we have the data that you shared with us for your practicum preferences. Accordingly, I will organize the sessions. I will organize the supervisory panels as well, and you will be assigned with the panel to work with. Okay, right. So we'll wind up the session, and for the advanced machine learning part, uh, Maninda will take on. And all right, so have a nice weekend then. Just send me a message if you find the session useful and you are eagerly looking to continue this. Okay.